This integral might look impossible at first, but it is not. It is all about trigonometric formula that you have to use here. In order to integrate the products of sine terms and the cosine terms, always remember you have to use defactorization formula of trigonometry. Defactorization formulas are the formulas which converts your product of sine and cos into either addition or subtraction. Okay, there are different defactorization formulas that you can use for the different combinations of the sines and the cosines term. In this problem, we are going to use the formula number 3, which is cos A times cos B. It converts the product of cos into addition. Okay. Defactorization formula always converts product into either addition or subtraction. In this problem, you can see three cosine terms getting multiplied, and we will use defactorization formulas to convert that product into addition and subtraction. Okay. My advice for the first step is always write those terms in the descending order of the angles. So for example, you can write cos 6x first, since it is product, then write cos 4x, and then write cos 2x. It is not mandatory step, but it just makes your calculation a little bit easier if those angles are in the descending order. Okay. Now take the first two terms and apply the defactorization formula. So I'll take the first term and the second term, and I'll apply the formula which you can see above. So you can write that cos 6x and cos 4x. Every formula starts with a half. So I will write a half. Then I'll put a bracket. Then there is cos. You add those angles. So A plus B. So you write 6x plus 4x. Okay. And then plus cos A minus B. So 6x minus 4x. Close the bracket, and then there is cos 2x with respect to x. Okay. This half is the constant value can be taken out of the integral. So this will become half integral of, I have cos 6x plus 4x is 10x plus cos 6x minus 4x is 2x times cos 2x with respect to x. I hope so far it makes sense. Now what you can do is multiply that cos 2x inside of that bracket, and let's see what do we get. Half integral of cos 10x times cos 2x plus cos 2x times cos 2x. You can also write it as cos square 2x, but I want to keep applying the defactorization formula, so I will not write it as cos square 2x. Okay, so I will have half integral of, let's put a box bracket. Okay, in the first term, let's apply the defactorization formula again. So if you apply the defactorization formula again, so I'll again get half. I will get cos A plus B. So you add those angles. So 10x plus 2x will give you 12x plus cos A minus B, which is 10x minus 2x, which is 8x. Okay, I hope that makes sense. I will apply the same formula in the next terms, which is, so cos times cos is again half cos A plus B. So 2x plus 2x is 4x plus cos 2x minus 2x is 0. I will close that box bracket, and my integral is with respect to x. I hope it makes sense. I just apply the defactorization formula in those terms. Okay. Now it is so easy to evaluate. You can factor out this half from year and year. This half can be factored out and can be taken out of the integral. So this will essentially become 1 by 4 integral of, in the bracket, I have cos 12x plus cos 8x plus cos 4x, and cos of 0 degrees is 1. Okay, so plus 1. Let's close the bracket with respect to x. Now we have converted that entire product into addition. Now you can easily integrate by just giving that integral to all of those terms. So you have basically 1 by 4, open the bracket. Let's give integral to all the terms. So integral of cos 12x with respect to x plus integral of cos 8x with respect to x plus integral of cos 4x with respect to x plus we have integral of 1 with respect to x. Let's close the bracket. Now we have 1 by 4. Let's open the box bracket. Integral of cos is sine. Okay, so cos 12x integral is sine 12x. Remember, in integral, we always divide by the coefficient of x. Okay, so coefficient of x here is 12. So we divide by 12. Remember, in differentiation, we multiply by the coefficient of x by chain rule. Since integration is antiderivative, we divide by the coefficient of x. Okay, so plus integral of cos 8x is sine 8x divide by coefficient of x, which is 8, plus integral of cos 4x is sine 4x, divide by coefficient of x, which is 4, plus integral of 1 is nothing but x, close the bracket. Let's add the constant of integration c, and that is your final result. Was it really that hard? We were able to convert that product into addition using just defactorization form. This was actually a trigonometry problem, not a calculus problem at this point. Calculus was only at the last step. I'll see you guys tomorrow.